Right now, while you are watching this, something is happening in deep space that almost nobody on Earth is paying attention to. A machine older than most of your grandparents is still alive out there. It is smaller than a small car. It runs on less power than a single light bulb in your house. And right now, from more than 15 billion miles away, it is sending back numbers that scientists say should not exist. Numbers that break the rules. Numbers that are changing how we understand the edge of the sun itself. This is not about space in some faraway way. This is about the air you breathe, the magnetic shield that protects your family, and the thin, invisible bubble around our entire planet that keeps you alive. This is the story of Voyager 1. If stories about hidden discoveries in deep space are what you came here for, then stick around, and if you have not yet, hit subscribe so you do not miss what comes next. In 1977, a young man named Carl Sagan asked NASA to look up into the night sky. He wanted one small thing. He wanted Voyager to turn its camera around one last time and take a picture of Earth from the edge of the solar system. That picture became the pale blue dot. A tiny speck of light, smaller than a single pixel, floating in a beam of sunlight. Everything you have ever known, every person you have ever loved, every war ever fought, every song ever sung. All of it sitting on that single dot. That was the beginning of the Voyager story. But the story did not end there. Voyager kept flying. It kept going. And almost 50 years later, it is still flying. That alone should amaze you. Almost 50 years. Almost a half century. Think about your phone. Think about the computer on your desk. If you bought the best one in 1977, would it still be running today? Would it still be talking to you? No, it would be a brick in a drawer somewhere. But Voyager is not a brick. Voyager is still alive. Still listening, still talking, still measuring. And the things it is measuring right now are the most important things it has ever measured. To understand why, you have to know where Voyager is. Take a breath. Hold it. And let me tell you the distance. Voyager 1 is more than 15 billion miles from Earth right now. Let that sit for a second. 15 billion miles. That is so far that if you tried to drive there in a car at 60 miles an hour, it would take you almost 30 million years. That is how far this little machine has gone. And here's the strange part. The radio signal it sends back to Earth is only 23 watts. That is less power than a nightlight in your bathroom. From 15 billion miles away. NASA picks it up using huge dish antennas, one of them 70 meters wide. And that signal takes 22 hours to reach us. 22 hours. You send a message, then you wait a full day. Then you wait some more. Then the message finally lands. Voyager is so far away that it is now in a kind of one-day delay land. It is the most distant thing humans have ever built that is still talking back. But here is the first plot twist. This is not the story you think it is. This is not a story about a brave little machine flying far. This is a story about something Voyager found that scientists did not predict. Something flying through what is supposed to be empty space. Let me explain. Around the sun, there is a giant magnetic bubble. Scientists call it the heliosphere. It is made by the sun blowing out a stream of charged particles in every direction like a steady wind. That bubble is huge. It stretches out past Pluto. It is what protects us from the worst radiation coming from other stars. It is one of the reasons life on Earth is even possible. The bubble stops most of the dangerous stuff before it reaches us. Voyager 1 crossed the edge of that bubble back in 2012. It became the first human object to ever leave our sun's magnetic shield and step out into the open space between stars. That alone was a giant moment. But what Voyager saw on the other side shocked the scientists. The space out there should be quiet, empty, calm. Sure, there should be a few cosmic rays, but mostly just nothing. That was the prediction. Models said the space between stars would look like a slow background noise, not much more. Voyager did not find slow and quiet. Voyager found something else. Let me describe what happened. Voyager carries a small instrument called the plasma wave system. It was designed to listen to plasma, which is just a fancy word for super thin gas made of charged particles. It picks up tiny vibrations in that gas and turns them into sound. Scientists had used this instrument for years to listen to Jupiter and Saturn, so they thought they understood it. When Voyager crossed into interstellar space, the instrument started to hear something strange. A faint hum. A low, steady signal, like rain on a tin roof very far away. This was weird. There should be no hum in empty space. The team checked the instrument. They checked the math. They checked every single thing that could go wrong. The instrument was fine. The data was real. And here is where it starts to get strange. The hum never went away. For years, the signal just kept going. Scientists published a paper in 2021 in a peer-reviewed journal saying they had detected persistent narrow-band plasma wave emissions coming from interstellar space. In simple words, they said something out there, something we cannot see with our eyes, was humming. And it had been humming since at least 2017, and it was still humming. This was the moment scientists started whispering to each other at conferences. Something was not adding up. Now let me give you the second plot twist, and this one is bigger. Back in 1993, when Voyager was still inside the bubble, scientists made a prediction. They said when Voyager finally crossed out, the density of the gas around it, the electron density, would jump up by about a factor of 20. A small step up, just a quiet confirmation that you had gone from inside the bubble to outside the bubble. How wrong that prediction turned out to be. When Voyager finally crossed out in 2012, the plasma wave instrument started measuring, and the density was not 20 times higher. It was about 40 times higher than what scientists had inside the bubble. The gas outside was almost twice as dense as the models said it should be. And then the strangest part, the number did not just go up and stay there. It kept going up for years, slowly, steadily, so much so that by 2015, the density was so much higher than expected that the models were basically broken. Scientists had to go back to the drawing board. This is what I meant when I said Voyager sent data that breaks known physics. The models of how the edge of the solar system should look, the same models that took decades of work by thousands of scientists, were contradicted by the actual measurements of one tiny spacecraft floating out there alone. Now let me slow down and tell you why this matters to you, not to some scientist in a lab, to you. That plasma hum, that extra density, that is not just numbers. That is the stuff of the interstellar medium. That is the real stuff between the stars, the real material that new stars are made of, the real environment our sun is flying through right now, even if you do not feel it. If the models were that wrong about what is right outside the sun's protective bubble, then what else might they be wrong about? What if the radiation coming in from those regions is not what we thought? What if the shielding we think the sun's bubble gives us is either thinner than we hoped or thicker than we feared? These are real questions, and they matter because every day the sun is moving through this exact same medium. Our whole planet is right now traveling through it. So this is not just some abstract space mystery. This is about the physical context of your life, the actual physics of the room you are sitting in. And then, in 2023 and 2024, the story got even stranger. Let me introduce you to the engineers, the Voyager team at NASA's Jet Propulsion Laboratory in California. These are the people who now spend their careers keeping two 48-year-old spacecraft alive. Many of them were not even born when Voyager was launched. They grew up hearing stories about Voyager, and now they sit in a mission control room and try to keep it talking to us from across the solar system. Around May of 2024, Voyager 1 went quiet in a strange way. It was still sending a signal to Earth, but the data inside the signal was garbage, random gibberish, zeros and ones that made no sense. It looked like Voyager had gotten confused, like an old brain losing its memory. For months, the team could not figure out what was wrong. They sent commands. They waited 22 hours for the reply. They sent more commands, again and again. And here is one small human detail that captures it. Some of the Voyager engineers have been working on these machines longer than most of the listeners of this video have been alive. They know Voyager the way a parent knows a child. They know when its voice sounds right and when its voice sounds wrong. After months of patient work, they finally found the problem. A single small chip on the flight data system, the onboard computer that packages up all the spacecraft's science data before sending it home, had failed. One little memory cell inside one ancient chip had stopped working. And because of that one cell, the whole brain of the spacecraft started forgetting how to speak. Think about that. 15 billion miles from Earth, in a place where no human has ever been, a single tiny piece of old technology broke. And the entire human race almost lost its only voice out there. The team then did something that almost no one thought they could do. They rewrote the code. They routed the data around the broken chip. They taught Voyager how to talk again without using that one bad piece of memory. In late 2024, the fix worked. Voyager 1, the little 1977 spacecraft, woke back up. It started sending clean, healthy data once more. And in that data, the strange plasma hum was still there. The density was still higher than expected. The mystery was still going. And that fix, that little human victory, is part of why this story matters. Because it shows you just how fragile the line is between knowing and not knowing, between science going forward and science going dark. Now I want to pause here for a second and think about what we have just covered. A 48-year-old spacecraft is alive. It crossed out of the sun's bubble. It is listening to a hum that should not be there. It found a density that should not be there. Its computer broke, and a tiny team on Earth fixed it from 1 billion miles away. There's a real possibility that a thin sheet of dense plasma sits out there past the bubble. Scientists have started calling it the wall. A wall of plasma, somewhere around 10,000 to 50,000 times hotter than the surface of the sun, sitting at the very edge of the solar system. Some scientists think it might be the boundary where the sun's wind finally loses its last breath against the pressure of interstellar space. Some think it might be a sloshing surface, like the edge of a glass being tapped. Some think it might even be the place where some kind of magnetic message gets sent in both directions. We are not sure yet. Voyager is one of the only ways to find out. If this kind of hidden story is what you came here for, you are in the right place. Subscribe now because the Voyager story is far from over. There is more coming, and most of the internet is not going to hear it first. Now let me move into the human side of this. Not the science, the people. The Voyager mission was supposed to last 4 years. That was it. 4 years to fly past Jupiter and Saturn and send back pictures. After that, the mission was supposed to end, but then it did not end. The team kept it alive. They turned off one instrument, then another. They rerouted power. They pulled tricks out of their pocket that had not been imagined when Voyager was built. There is a moment that makes me stop every time I think about it. In the late 1990s, scientists realized that Voyager's path could be slightly adjusted using its small thrusters. But those thrusters had not been fired since the planetary flybys. They had been sitting cold for more than 20 years. No one knew if they still worked. The team sent a test command, and the thrusters fired. After 20 years, they fired. They had not lost a single beat. That tells you everything about the spirit of this mission. The people behind Voyager refuse to let it die quietly. Every year is a fight. Every watt of power is a precious coin. Every instrument is a hard choice. Today, the team is shutting down instruments to save power. They shut off the cosmic rays subsystem on Voyager 1 in early 2025. The low-energy charged particle instrument on Voyager 2 went off in March 2025. These are real instruments that helped humanity understand the boundary of the sun for decades. The team is turning them off, one by one, because the little nuclear battery inside Voyager is slowly fading. Not quickly, slowly, but fading. This is the third plot twist of our story. The clock is real. There is a real deadline, and it is already locked into the team calendar. By the early 2030s, maybe a bit later, if the team can squeeze every last drop, Voyager will not have enough power to run any single instrument. The little radio will go silent. The signal will vanish. The most distant human voice in the universe will fall quiet. And the little spacecraft will keep flying. It will keep floating deeper into the galaxy for millions of years, a silent metal ghost. But we will not be able to talk to it. We will not be able to hear it. We will not even know it is still there. That day is coming. It is on the calendar. It is not a guess. And that is the strange weight of this moment. Right now, today, while you're watching this video, we are at the very last window. The last few years of the Voyager era. The last few years where a single machine, smaller than a compact car, is still telling us what the space between stars is really like. Once it goes silent, that window closes forever. There is no second Voyager behind it. There is no backup. By the late 2020s, this is it. So when you hear about the plasma hum, when you hear about the wall of hot plasma past the bubble, when you hear about the density readings being way off, please understand, this is not a story for scientists. This is a story for the human race in its last few years of hearing from the only witness we have. And the witness is telling us things we do not fully understand. Now let me tell you the deepest part. And I want you to sit with me here for a moment, because this is the part that does not make the news. Voyager is powered by a tiny plutonium battery, not solar panels. Solar panels would not work that far from the sun. The battery generates about the same power as a couple of old phone chargers. Every year, it puts out a few watts less. There is no way to recharge it. It is just slowly going cold. The team has planned for this. They have planned for the silence. They know the date. They have even built the very last command they will ever send. A command that will turn off the transmitter, or that will at least signal the end of the science mission once power is too low to do anything useful. That command has a name. That command has a date. And when that day comes, in the early 2030s, a person somewhere in California is going to press a button, send the last signal, wait 22 hours, hear the last reply from a machine that has been flying since the year disco died, and then the room will go quiet. And here is what makes my chest tight when I think about it. By the time that last message is sent, the original Voyager team will mostly be gone. Some of them will be retired. Some of them will be gone in a different way. The Voyager mission will have spanned almost 60 years of human engineering. From the very first engineers in 1972 building the spacecraft in a clean room, to the very last engineer in the early 2030s, sending the very last command. That is a single chain of human hands, touching the same machine across almost 7 decades. No mission in human history has ever done that. And the machine itself will keep flying, long after the sun has burned out, long after Earth has changed, long after the last human is gone. Voyager will still be there, drifting, carrying a golden record full of human sounds, greetings in dozens of languages, a baby's cry, the sound of wind, a song. Those recordings were meant for any intelligent being out there who might one day cross paths with this tiny metal scrap. And now, almost 50 years later, we are still adding to that story, still adding science, still adding data, still keeping that little golden message alive in the most literal way. Now think about that for a second. You are alive at the exact human moment when this little spacecraft is still talking to us. not in some abstract way, in a practical, real, today way. The data that is breaking physics, the data that is rewriting what we thought we knew about where the sun's protection ends, that data is coming in right now. This month, this year, you are watching this in the final window. After this window closes, no one alive today will ever hear from the spacecraft again. That is not a story from long ago. That is not some dusty museum piece. That is happening right now. Right now. So what does this all mean? It means that the boundary of your solar system, the boundary that is supposed to keep you safe from deep space radiation, is more complicated than we thought. The gas just past it is denser than we predicted. There's a hum in that gas that we did not predict. There's a hot wall that we did not fully understand. And if our models were wrong about those things, they may also be wrong about how stable the bubble around us really is, about how much galactic radiation gets through, about how risky long-duration deep space travel will be when humans finally try to go to Mars or beyond. These are the kinds of details Voyager was built to give us, and it is giving us new ones right now on the edge of silence. It also means something softer, something quieter. It means that an old, small, almost forgotten machine is still beating the odds, outlasting the engineers who built it, outlasting the missions that were supposed to retire it, outlasting every prediction that it should have died by now. It is the underdog story of the human space age, a tiny craft with barely any power in the cold and the dark, still calling home. And the strangest part of all, we built it to see planets. We built it to take pretty pictures of Jupiter and Saturn. And it has ended up doing something we never asked it to do. It has ended up being the first weather station for the space between the stars, a place we did not even know we had to take the weather for. That is not nothing. That is not small. That is the kind of twist that changes what a whole mission means decades after it launched. Let me take you back to the beginning. Carl Sagan's pale blue dot. A tiny speck of light, smaller than a pixel. That was 1990. Now, in 2026, Voyager is 15 billion miles past that picture. It is still moving. It is still whispering. It is still teaching. It is still correcting us. The spacecraft that took the most famous picture in human history is still working. If you want to follow what comes next, the next instrument shutdown, the next unexpected plasma signal, the next wall, the next density jump, you can do something right now. Press the like button because that single tap tells the algorithm that this kind of under-the-radar science story matters. Drop a comment with your honest guess. Will Voyager still be talking to us in 2030? Will it be talking in 2032? Will we get one more mystery from it before it goes silent? Say what you think. Tell me what you think the hum might be. Tell me what you think is out there on the other side. And share this video with one person, who is going to lose their mind over the fact that a 1977 machine is still rewriting science right now.